Okay, now let me run Arduino. Now, if you have Bluetooth turned off on your Android phone, you will be prompted to activate it. Of course, if you run the application for the first time, it will ask for permission to access your Bluetooth. Okay, meaning the application wants to be able to turn Bluetooth on, and we will say yes. Okay, now Bluetooth is turned on, but we're still not connected to the HC05 Bluetooth over serial module. Before we can connect, we have to pair. Pairing is done once, and it basically authorizes your device, your Android device, Bluetooth, to communicate with the HC05 or any other Bluetooth device. Once you do the pairing and you exchange the passcodes, all you have to do after that is just directly connect. Okay, so let's click on the action menu and say connect me to a Bluetooth device. If your Bluetooth device is not discoverable, you will be asked to make it discoverable. Okay, it says no Bluetooth device has been paired, so there has been no pairing of any Bluetooth devices between my Android and the HC05 here. So I want to scan, and here it gives me an option. The HC05 is basically the Bluetooth device name, the default device name for the HC05 module that I have here. If I select it, I'll be prompted to enter a password or the passcode. Again, this is done only once during pairing. The default passcode for the HC05, which you can change. You can also change the name, but that's a different topic. It's 1, 2, 3, 4, and okay. Now watch the light stop. It used to blink continuously. Now it just blinks twice every 1 second or so. Now we have a connection between the Arduino and the Bluetooth module, the HC05 Bluetooth module. And the double blinks every 1 second or so tells me that the connection or the pairing has been made successfully, and now we have a connection. Okay, let me explain Arduino, the user interface. It's divided into 4 sections based on the functionality. The top one basically is a list of sliders, and I can use those sliders to control the corresponding pins. Note that these pins are the pins with pulse width modulation capabilities, meaning that these are pins that you can control with the analog write command in Arduino. The second one is a digital write keypad, and here we have 12 buttons, each one corresponding to a digital pin on the Arduino Uno. I have excluded pins 0 and 1 because they are used frequently for serial communication. Maybe I should return them in a later release. I don't know. We'll see what the users say. So when you click a button, you're actually toggling on and off from high to low, high to low, high to low, etc. Okay, and then the third section is the send data. Here basically I can type anything I want. Okay, click, 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 done, and then I can send it. And then on the Android side, my code will process this data to take whatever action I want. And finally here, it's get data. And what get data allows me to do is to basically receive data sent from Arduino to my Android. And I can decide what this data should be. I can read sensors, read pins, whatever. Okay. And with the send data, I can send text data to show on LCDs, etc. Okay. So now let's try and test this application. First thing I want to do, I want to control the brightness of the two LEDs. The first one is connected to pin 11, so if I slide, watch the LED on the left, increase in brightness and decrease in brightness. Again, maximum brightness and halfway brightness. Oops, big thumbs, and zero brightness. One more time, maximum brightness, no brightness. Second one, same thing. Okay, I can also toggle these LEDs on and off. 11, 11, 11, 11, 10, 10, 10, 10. Okay, let's send data. I don't have anything right now to test it with, but basically it's as simple as clicking whatever information that you want, done, and it sits here in the text field until you're ready to press send data. Like I said, the Arduino receives this information and you can decide in your code on the Arduino what you want to do with this data, such as displaying it on an LCD screen or controlling a motor or servo or what have you. Here we have send data, receive data, sorry. Right now my sample code on my Arduino is wired to read analog pin 0, and since analog pin 0 is not connected to anything, it's just basically reading ambient noise. But I can connect it to sensors, LDRs, what have you. And this is basically Arduino in a nutshell. I plan to add more features in the future if there is really a need for such a tool. Let me just explain the test circuit that I'm using for the Arduino. Basically, I have an Arduino Uno and I have the HC05 Bluetooth over serial module, which I bought from eBay for less than 10 bucks. There are two versions, one without the breakout board. It's a nightmare to use. And then there is this one for a couple of extra bucks. It comes with a really nice breakout board, LEDs to let you know when the Bluetooth has been paired, when it's not, and it comes with current limiting resistors and male header pins, so you can fix it on a breadboard. Now, please note that this HC05 module is a 3.3 volts circuit, even though it has a regulator, a 3.3 volt regulator. This is just to regulate the power to the module, but not to the pins. Of interest is the RX pin, which gets its signals from the Arduino's TX pin. The Arduino is a 5 volt system, so when Arduino's TX pin is wired directly to the HC05, you're actually running the risk of ruining your HC05, because the HC05 RX pin is expecting a 3.3 signal, while the Arduino's TX pin, which is pin 0, pin 1, sorry, is actually sending a 5 volt signal. So there are two ways to actually deal with this 5 volt to 3.3 volt conversion. You can either use a straightforward voltage divider, which you can use different values for your resistors, such as 1K and 2K, or you can use a level shifter, such as the IC I'm using here. which I also bought from eBay. You can use a number of ICs to do this job. In my other guides, I've used voltage dividers, resistors as voltage dividers, and it worked fine. Here I wanted to try something different, so I used this level shifter IC. Okay, I have two LEDs, both connected to pins 11 and 10. Those LEDs are connected to what's called pulse width modulation pins, which means I can control them with an analog write command, as well as controlling them with a digital write command to turn them on and off.